Hello friends, today I am here to discuss about our project Action and Content Based Community Detection in DBLP. Now let us first define what is a community. A community is defined as a group of nodes which are densely connected inside the group and while loosely connected with the nodes outside the group. That is a dense graph within a sparse graph. Now example of a community can be Facebook groups or political parties, etc. What is community detection? Community detection in graph aims to identify the modules and possibly their hierarchical organization by using the network structure and attributes of the nodes. Why do we need to identify communities? There are four major reasons to identify communities. Identifying group behavior, decreasing network traffic, increasing more relevant results in searches, and link prediction. Identifying network behavior. There is a general tendency that people belonging to same community tend to show similar behavior. So if we are aware that a person is showing same behavior, then if we are aware about the community to which he belongs, then we can predict the similar behavior for other people of that community too. Decreasing network traffic. If I am aware that these group of people belong to the same community on my social network, then I can put them on the same server so as to avoid more intra-server so as to decrease inter-server traffic, as there is a high possibility that people belonging to same community will interact more. Increasing more relevant results in searches. If a person is searching for some XYZ person belonging to a community, then it is a high chance that the same person will search for the people belonging to the same community, so I can show them in my search results. Link prediction. If a person enters new in a community, then it is a high possibility that he or she will build new links with the persons belonging to the community with whom he doesn't have a link by now. Now I'll describe you about our dataset, that is DBLP dataset, which we have used in our project. It is a highly evolved dataset since it has been collected since 1993. You can see a snapshot of our dataset which describes the organization of articles in our dataset. In our dataset, there are four major things: article, in proceedings, master thesis, and PhD thesis. Each of them are described as follows: the author's name, the title, pages. If it is a journal paper or conference paper, then the pages of the journal paper in where it has been published, the year in which it has been published, the volume of the journal paper in which it has been published, and a link to that article. Some statistics about our dataset can be seen on the slide. The number of publications are around 29 lakh, the number of authors are around 15 lakhs, the number of conferences are around 3700, and the number of journals are around 1400. Now problems in community detection. It is an NP-complete problem in the sense that it is analogous to a theoretical problem of finding a click in a graph, that is a proven NP-complete problem. Now next thing, the next problem is more of a practical problem in the sense that that it has been observed when practically we try to find the different communities. This problem can be stated as follows: every actor in the graph has variety of attributes, so deciding the attributes on which edge weight is to be given is a tough job. This is a tough thing in the sense that these edge weights decides how our communities will be divided. Now let me explain to you how we approached our solution of finding different communities in the DBLP dataset. Our raw dataset was in the form of an XML file, which we first converted into MySQL tables. These tables there were two tables here, an author-wise table and an article-wise table. In the article-wise table, we organized the data in form of an article ID, the title of the article, the year in which it was published, the journal paper in which it was published. The author-wise table contained the details which author has published which article. Now these things were converted to CSV file so that these tables were processed first and then converted to CSV files which we use to create graphs. On analyzing our dataset, we found that we could use 4 metrics to construct our graphs: co-authorship, closeness, titles, and no attributes. That is, we considered all links in our graph as having the same weight. Then we applied the Lovian algorithm on these graphs to compute various communities. To compute the qualities of the communities detected, we use modularity metric. The modularity function can be defined as q is equals to sigma I is equal to 1 to k in brackets li upon l minus di upon 2 l the whole square, where l is the number of edges in the graph, li is the number of edges between nodes within community I, and di is the sum of degrees of the nodes in community I. Constructing graphs on a dataset involves selecting attributes on whose basis we have to construct the graph. We constructed 3 graphs on our dataset on basis of co-authorship, closeness, and considering that all edges have the same weight. Based on co-authorship, we defined co-authorship as the fact that 2 authors have published an article together. We have put an edge between them. The weight of the edge depends upon the number of papers 2 authors have published together. Based on closeness, closeness can be described as a Jacquard similarity. This metric is defined as the division of the number of common neighbors between 2 authors upon the square root of the multiplication of the number of neighbors of each author. The results which we found upon application of Lovian algorithm on the 3 graphs which we had constructed and finding the modularity on those graphs were as follows. Considering that each edge has same weight, then we found 40,529 communities with modularity of around 0.8056654. Co-authorship, we found 40,182 communities with modularity 0.81051, and closeness 21,265 communities with 0.94646 modularity. This implies that closeness or Jacquard similarity is the best way to find communities in a DBLP dataset. Thank you.